So now it's it's tricky, right? They're going to give you a graph of some motion, and they want you to come up with to derive things from it. Okay, so find the period, find the amplitude, write an equation for the position. By the way, the equation is going to involve finding what omega is, right? So that's going to be a little bit tricky, right? Okay. So the first thing is to find the period. You can either go from peak to peak, which isn't terribly convenient here, right? Or you can go from, this is the middle going down to the middle going down, right? Well, if you look at that, that's just 2 seconds, right? So our period is 2.00 seconds, right? The amplitude is just this, right? So if we go that, it looks like it's right between 4 and 5. So I'm going to say the amplitude is 4.50 meters. So this is our x naught, is that our period is 2.00 seconds. And then remember that omega is 2 pi over the period. So this one's pretty simple, right? This is our first one, so we got to be pretty simple. So 2 pi divided by 2 seconds is about pi radians per second. If you had to commit to a number, we'd say 3.14 radians per second. That's our omega, right? All right. All right. So write an equation for its position. Well, take a look at this. This one's like non-standard, right? Doesn't this look like negative sine? So I think, x could be x naught sine omega t. I have a hard time with omegas, right? But this one goes down, it doesn't go up, right? So isn't it just negative sine? Okay, now having said that, the corresponding velocity equation is just negative omega x naught cos omega t. And the reason I say this is that if you look at the one that goes with x naught sine omega t, it's just omega x naught cos omega t. If this one's negative, this one is too. Okay, it's pretty simple, right? So let's write an equation for its position. That's going to be the opposite of, and our x naught is 4.5. That's meters, right? Times sine, and then what's our omega? I'm just going to go with the pi, right? You could say 3.14 times t. Okay, now we've just written this down. The question is, is it true? Does it work? Okay, well, let's pick some spot here. Let's pick 3.2 seconds just for kicks, right? Well, where does that intersect? Somewhere in here, right? Somewhere like there-ish. Okay, so the question is, can we get that from this? So let's just try it, right? So I'm going to go the opposite of 4.5 times sine of pi times 3.2. And let's see if that gets something that looks to be about, what, 2.6 or something like that. Let's see. 2.64. 2.64. So it seems to work. And you could try a few more points. You could even graph it on your calculator and just check it. Okay, those are ways to check your answer. So it looks like this one's good, right? And then write an equation for its velocity. So that's going to be the opposite of our omega is pi, right? Times 4.5 is our x naught, right? Okay, and then cosine pi times t. Now, if we have to commit to a number, we would say the opposite of pi times 4.5. This ends up being about 14.1, right? So we could say negative. This isn't better. I'm just saying this is another way they might want you to write it. 14.1 cos pi times t. By the way, this is our omega x naught. This is our maximum velocity, right? So we've kind of already accidentally done a little bit of calculus here, right? The maximum slope, which by the way is occurring right here, right there. There's negative slope and positive slope. That maximum slope is this, 14.1. Okay, and then extra credit, right? One for its acceleration. Well, acceleration is what, just negative omega squared times x. This is what x is, right? So let's write that. Negative pi squared, okay, times x, which would be the opposite of x naught sine omega t. Okay, so we can plug numbers in here, right? X naught is 4.5. So if I go the opposite of the opposite, so these are going to be positive, right? So pi squared times 4.5, I get that it's 44.4. Let's see, sine omega t, and omega is pi, right? So I don't know, we could write it as numbers, right? 3.14 would be pi kind of as a number with 3 sig figs, right? Times t. This would be our formula for what the acceleration is, okay? Now we could check that, right? We should get at 4.5, right? At 3.5 seconds, I should get that the acceleration is, let's see, our x is 4.5, so it should be pi squared, the opposite of pi squared times 4.5. Let's try that. Well, it's 44.4, right? Okay, so let's just try it. Let's go that number times sine pi times, that's 3.5. You ready for this? Ho ho! I get opposite of 44.4, so this seems to work as well, okay? I think that's all there is. So if you get a graph like this, don't freak out. Just read things off the graph, figure out the period, figure out the amplitude. Yeah.